Hey everyone, my name is Brian Lagunas and I am a senior product owner at Infragistics. I am also a Microsoft MVP. I am a speaker, a trainer, and a Pluralsight author. And I'm also well known for owning and maintaining the very popular Prism library. I also post a lot of video training material on my YouTube channel at youtube.com/Brian Lagunas. If you ever want to reach out to me personally and ask a question, feel free to contact me on Twitter at twitter.com/Brian Lagunas. And I also live stream on Twitch. So if you ever want to see me struggling with code, just like everyone else, feel free to follow me on Twitch at twitch.tv/Brian Lagunas. As I mentioned, I am a senior product owner at Infragistics, and here at Infragistics, we provide the tools and software that you need in order to build your apps in half the time. We provide hundreds of UI controls and components for you to use in your various web-based or desktop-based applications. Everything that ranges from Angular to web components to React to Blazor, all the way to desktop applications such as WPF, WinForms, getting into cross-platform with Xamarin, Uno platform. Basically, if you have a platform that you're developing for, chances are we provide tools for you to use on that platform. We also just recently released a new app builder product called Indigo.Studio App Builder, which allows you to use a web-based WYSIWYG editor. And WYSIWYG basically means what you see is what you get, right? It's a drag and drop editor that allows you to design your entire application. And with one click of a button, it will generate all the code for that app. So you generate the code and you run the app, and it's beautiful. It's pixel perfect, just as you designed in the editor. Generate the code, run the app, boom. It's beautiful. Now, I would love to sit here and talk all day about all the great products that we provide, but today I'm here to talk about yield return. Now, when you're writing your applications, primarily a .NET Core application, C#, you may have seen this statement. It's a yield statement, mostly followed by a yield return. And this is kind of a confusing feature of the .NET framework or of .NET Core. And so if you've seen this and you don't really know what it does, well, that's what I'm here to talk about. I am here today to show you exactly when and why you would use the yield return statement. Not only that, there are two different ways we can use this code, right? We can use this in a synchronous manner, or we can use this in an asynchronous manner. So in today's session, I'm going to cover everything there is to know about yield return. And so hopefully by the end of this session, you'll know where and when to use it in your own applications. So let's go ahead and get started. So the application we're working with today is a very simple .NET console application. And before we really get into what yield is and where we would use it and all that, let's first take a look at how we normally write code. You know, this is the code that you're most commonly going to see. In our main method, we have a method called process people. And if we look at process people, we'll see that it's pretty basic. We call this method called get people. We loop through those people. And it looks like we're checking the ID. If it's less than 1,000, we're going to console write line. Otherwise, we're going to break out. So we're looping through all these people, and we're only going to take the first 1,000 of them, it appears, right? And so if you look at this get people, we're passing in, what's this, 1 million? So we're passing in the number 1 million. Actually, to make this easier to read, I'm just gonna use that little shortcut there, right, to help me visualize that that's a million. So we're passing in the number 1 million. And what this method does, this is very common, right? What we do is we create a list because we want to hold this list of people that we're creating, right? So we're going to loop through this count, and for each one, we're going to add a new person, right? We're going to create a new person, we're going to add it to our list, and then we're going to return this list. And this is a very, very common way to return a collection of items from a method, right? We create some type of temporary list or temporary collection, and then we return it from the method. And sometimes that's all that method does. And it's pretty straightforward. So I'm just gonna run this as it is. And all it did was it went through the first 1,000 people, and then when we got to our 1,000th person, we stopped, right? We broke out of the for each loop, and the application is over. But what we want to do is we want to step in and see what's really going on here. What are we really doing when we call this get people method? Okay, so I'm gonna start here. I'm gonna put a breakpoint there, and let's run this again. And so we enter this process people method. Okay, the first line we get to is get people. We're going to get 1 million of them. So we're going to step back into this method. We're going to create our people list, and then we're going to loop through each one of those for each count, each number, and whatever count we throw in there, we're going to add a new person to the list. So no matter what, we're going to loop through and create 1 million people and return that collection no matter what, right? So when we get to the people, we can hover over this and see that we sure do. We have a count of 1 million, okay? And so that is a completely populated object. And now no matter how many people we actually wind up looping through, no matter what, we've already created 1 million people, right? No matter what, we have created 1 million people. And so this is where the yield return keyword kind of comes into play, okay? What we want to do is we want to prevent us from actually creating all 1 million records, adding it to a list and returning that list fully hydrated with 1 million records. Instead, wouldn't it be great if we could just only return what we want, okay? So I'm going to modify this method here, get people. I'm actually going to delete this list. We're not going to be returning there. We don't have a list to add to anymore. Instead, we're going to say yield return new person. Okay, so we fixed that. And now let's step through this again and kind of see what happens. What's going on here? Okay, so I'm going to put a breakpoint on this get people. And let's go ahead and run the application. So our first line is get people. We're asking for 1 million of them. Whoa, well, that's weird. We actually didn't get into the get people method, did we? We never hit this method. We went straight to the for each. And if I hover over the people, I can see that we actually don't have a count at all. Well, that's very strange. Well, what's going on? Well, let's keep going, right? Let's keep going and see what's happening. So now we're going to slowly come into this for each statement. And so for each person and people, right, we're in the in statement now. We're highlighted on in. Now we get people, right? And now we're going to come through here and we're going to return a person in this ID. What's this ID going to be right here? 0. Okay, now we have a person. Okay, now we're going to come through here, check the ID, console write line, and we're going to keep stepping through. We're in again. And now we're going through one at a time, but let's hit that breakpoint here. Okay, so now I'm gonna come back and I'm back in. Did you see what happened? We went from in and now we're inside this loop again. We didn't hit the outside code block for the get people method, right? We hit that once, but we haven't hit it again. Instead, we're still inside this loop, right? So I'm gonna yield return another person. We have that person. We're in the in statement again right here, that in keyword. Boom, we're back into the loop. So what we're doing is we're essentially lazily iterating over this collection here. We're only requesting one person at a time, okay? So as we go through here, for each loop, for each iteration, we're going to come into this method. It's going to remember where we left off, and it's only going to return that person that we're requesting at that time. Okay, so I'm going to go ahead and I'm going to remove all my breakpoints, and then it's going to work the same way, right? We get the same experience, except we made a huge change that basically will help improve performance and memory usage. And we're going to see that in a minute. Before I show you our benchmarks, I kind of want to discuss what's kind of going on here. When we use the yield statement, what are we really doing? Well, we're basically creating an iterator. Okay, we are creating an iterator. And if you don't know what an iterator is, you use them, you just probably don't realize it. So for example, I'm just going to write some pseudocode up here. I'll say var test equals get people. We'll pass in, doesn't matter how many. And then we're going to say get enumerator. Right, so each collection is going to have what's called an enumerator. And the enumerator is responsible for iterating over the collection. So if I come into this definition here by hitting F12, we can see that it returns an enumerator that iterates through the collection, okay? So essentially what a for each statement does, it's syntactical sugar over something like, while test dot move next, we're going to, var item equals test.current. That's essentially what a for each is doing. A for each is just syntactical sugar over something like this. This is kind of what it compiles down to roughly. Okay, so this is all syntactical sugar on top of the .NET underlying workings. Okay, and so by not having to iterate over the entire collection or create an entire collection, we didn't have to actually create a million people, a list with a million people in it, did we? No. What wound up happening is we actually looped through and only created the first 1,000, right? We only iterated and created 1,000 people because using yield, when we came into this loop, right, we only requested the person creation one at a time as we needed it. And the second that we got over that 1,000, we broke out of the for each and we were not requesting anymore. Now, let's look at some benchmarks. I've created a couple of benchmarks here, and this is going to show you the time and memory impact that doing it the old way, which is just process people. It's the same method. I didn't change anything. And then we have the process people yield. This is the yield approach where we are using the yield return result. Okay, same method, same everything, but we're going to benchmark and measure these. So in order to do this, I'm going to comment out our test code here, and I have to put something like var summary equals, what is it, like, I think it was benchmark runner. Yeah, benchmark runner dot run, and then the name of my class, which is yield benchmarks, because I'm using benchmark.net, and this is what I'm using to benchmark all of our usage on our methods. So I have a memory diagnoser, and I marked each of these methods as a benchmark. In order to do this, I have to run this as release. And let's go Control F5, and let's run these benchmarks and see what the difference is to our applications when we use the old create a list, create everything, and give it back to you, versus, you know what, I'm going to create a yield iterator method, right? It's a method it's an iterator. That's all it is. So this is going to take just a moment to complete. I mean, we are creating 1 million records in one of the tests multiple times. So this benchmark actually runs your methods multiple times in order to get proper results. And it looks like it ran it 15 times. So it's going to run each one 15 times. Okay, so now that this is done, let's look at the results. The process people method, this is using the old school create a list, create everything, put it in the list, and then return it. That took 314 milliseconds. Versus the process people yield, where we're only requesting what we want when we want it, 79.51 milliseconds. But also look at the memory usage we have here, right? That is a massive, massive difference in memory. Basically, we'll call it 118 megabytes versus 186 kilobytes. That is huge, right? That is huge. Now, it's important to realize that what's going on here, when you use the yield, right? When we're using this, we're creating essentially a custom iterator. And if you don't know what a custom iterator is, it's a class that implements IEnumerator, and you have various methods you have to implement, such as the current, such as move next, and things like that. When this compiles down, it actually creates that class for you automatically. So this, like I said, it's syntactical sugar. It makes things a lot easier for you. Now, what's also cool, if we kind of go back, no, we'll stay in here. You can use yield as properties as well. So if you had a property, like, I don't know, IEnumerable of int, right? We'll just call it my property, and we'll have just a getter here. We can, return. No, we can yield return, 0. We can yield return 1, 2, 3, 4, right? So we can use yield return not only in a method, but you can use it in properties as well. Very, very handy. Though I don't do this personally very often because this really won't buy you too much, but it's possible. It's something you can do. So when you go to ask yourself, Brian, when would I really use the yield keyword? Well, really, you're going to use it with like large collections. This is very beneficial for very large collections. Any collections that maybe have an infinite length, like you don't know when it's going to end. When you're dealing with streams, I know a lot of IoT developers use yield because they're feeding streams of data from the IoT device to the client-side application, right? The application that's reading data from that IoT device. Or when you're doing calculations with unknown results, yield is very handy. And so, when you go to look at using yield, I would always recommend, benchmarking your code and seeing if it's necessary. Because, for example, what happens if we take this down to, 1,000? How much does it really buy us? Let's look, right? Let's look. What do we buy ourselves when we just are only doing 1,000? Let this run. This should run much quicker now because we're only doing 1,000 instead of 1,000,000. Okay, so that's all done. Let's take a look here. So process people, 81.75 milliseconds. Process people yield, 81.55. So not really too much faster, hardly at all. It's very negligible. And then you look at the memory allocated, you still save a little bit on memory, but these aren't very vastly different numbers, right? They're very similar. But keep in mind, when you do use the yield, you are creating an iterator class, right? So it just depends on your use case. You're not always necessarily going to benefit from using yield from performance or memory necessarily if you have small collections you're working with, right? Anyways, I really hope this helps you understand what the yield is used for and how it kind of works, right? It's a lazy iterator, right? You're lazily creating things. You're lazily asking for things. You're only asking for them when you need them, at the moment you need them. You're not creating them all up front and then giving the whole shebang to you all at once, right? Well, now that you've seen how to use yield return in a synchronous manner, which is probably the most common, your next question would be, well, Brian, I have a lot of asynchronous code where I'm dealing with tasks and awaiting these tasks. And, how would I use yield return in an asynchronous manner? Well, I'm glad you asked because the next portion of my session covers just that. Now I'm going to show you how we can use the yield return statement in asynchronous code. So let's go ahead and jump into it. So the application we'll be working with today is a simple WPF application. It has a single window. And as you can see, this window contains a button that says read file and then a list box. Now, what I want to happen is when I click this button, we're going to read a file. That file being this file.txt file. And all this file contains is some copy and paste from a blog post I was writing last week. And what I want to happen is when I click this button, I want to loop through that file, each line, read each line one at a time, and add it to the list box. Okay, so if we look at our code behind for the read file click event, we'll see that we are grabbing the path to the file. We are then calling a method called getLines. And if we go to getLines, we can see, okay, yep, we're returning an enumerable string. We're going to create a list. We're going to use the stream reader to read that file one line at a time. So we're calling file.readLine in a while loop. Okay. We're just going to put a little sleep in there, just a little pause, right? To make it take a little longer. Otherwise it'd be very fast. And then for each line we read, we're going to add that to our lines collection, return it to our click event, and then we're going to loop through each of those lines one at a time and add them to our list box. So let's go ahead and run this application as it exists right now and see how it behaves. Okay, so here's the application running. What I'm going to do now is I'm going to click the read file button. And all of a sudden, I cannot interact with my app anymore. It seems frozen. It's non-responsive. Do I even know if this thing's working? I'm not sure, but I'm just going to wait and hopefully it just comes back, right? What I expect to see is that we'll see a file appear in the list box. So we're waiting, still nothing. Ah, there we go. Okay. So that took a while. That took a long time. And during that process, not only did it not add one line at a time to our list box, because what I want to see is I want to see this first line appear, 300 milliseconds, second line appear, 300 milliseconds, third line appear, right? I want to see it add one at a time. Not only did that not happen, but my entire application was deadlocked. It was frozen at the time. I couldn't interact with it. And that is not good. So how do we go about fixing this? Okay. Now, your first thought is, well, Brian, first of all, you know what? I saw your video last week on using yield return. So what if we use yield return to return one line at a time? How about that? That way, when we loop through these lines, we're requesting them one at a time, right? That makes sense, okay. So let's do that. Let's start by, we'll convert this to using yield return. That means we don't need any of that code. What we do need is a yield return here. We'll say yield return line, right? Let's see, what else do we need? And that should be it, right? That's how easy it is to convert our getLines method to use yield return and return one line of the file at a time. So let's see if this behaves any differently. So now what I'm going to do is I'm going to run the application again, wait for it to run. Here's the app. Let's click the read file and wait a minute. Hold on. This is okay. First, I'm going to put a breakpoint here. I'm going to put a breakpoint here. Let's step through this. Okay, list box at okay, in. I'm back in my while loop. I'm yield returning. I'm back at, okay, so this is working. This is totally working, Brian. What the heck is going on? Why isn't each line of that file being read into the application? Instead, what we have is the application waits, it's frozen, and then suddenly everything appears, right? Because if we look at our code, we can see that we have a sleep, right? We're yield returning, but the problem is this is still all on the UI thread, right? So no matter what, it's still going to take the same amount of time before everything just kind of pops up and shows. So now the next thought process is, oh, well, Brian, if it's all on the UI thread, well, then we need to put this on some type of asynchronous work, right? We need to make this asynchronous. And you would be right. We need to pull this work off the main thread somewhere else to where it can happen asynchronously to not lock up our UI. So now you're gonna say, oh, I know how to do that, Brian. What I'm going to do is I'm gonna see if readline has an async version. And it does, so readline async. So let's change this to, we're going to await the file.readline async. We have to make sure that we put our async await here. Okay, now we have our get lines, and then normally you would say, oh, okay, well, this is gonna be a task. We need to make this a task because it's async now. So we've got to return a task of IEnumerable. And we can't have a thread.sleep because we want to await a task.delay here, right? Everything's async now. We'll make that 300 milliseconds. And then you may think, okay, it's a task now. So now we have to await that. So let's put an async await here because we have to await the task, get the lines, and go through all of them. But, you know, we're having an error here, like something weird's going on. And what this says is that the body of getLines cannot be an iterator block because task IEnumerable string is not an iterator interface. So what this is telling you is that when you try to use yield return in an asynchronous method, it cannot return a task. Well, that's kind of different, right? How do we make something asynchronous, but not a task? And a requirement of yield return is it has to return an IEnumerable. So how do we fix that? Well, luckily for us in C#8, there is something called Async Enumerable. So Async Enumerable allows you to use yield return in an asynchronous manner. Okay, so this is going to return Async Enumerable of string. This allows us to keep this method asynchronous, right? So we're going to await readline async, we're going to await our delay, and then we will yield return. But now something interesting happens in the code up here. You can see that, well, wait a minute, how come I can't await the getLines method now? You know, we fixed the getLines method, it's now Async Enumerable, but if we look at this, well, it's not an awaiter, it's not a task. You could only await tasks, right? Well, how's that work? If there's no getAwaiter, how do we actually await the getLines method? Well, what we have to do is something a little unique. And you may have not seen this before, but what we want to do is we actually want to await the for each statement, right? So I'm gonna move that await from getLines, and I'm gonna put it on the for each statement. So now we're gonna say await for each var line and lines, where lines is our getLines method returning Async Enumerable. So now let's go ahead and run this application and let's see how it functions now. So I'm gonna go ahead, I'm gonna hit read file, and as you can see, it is reading one at a time. So I'm gonna hit a breakpoint here, I'm gonna hit a breakpoint here, And I'm going to loop through, and we're going to, asynchronously, lazily request one item at a time. So we're going to add that. We're going to go to the in statement here. Now we're back into the while loop. We're going to wait our delay, return one line at a time. We're back at our line, back to adding it to the list box, back to the end, back to the while statement. So it remembers where we were. So we are asynchronously returning one line at a time from a file we are reading. So I'm just going to remove these breakpoints, play the application, and there we go. And as you can see, the scroll bar is changing size because we're adding more and more items to this list asynchronously. So now you can kind of think about how this could be really helpful if you are reading in some type of stream, some never-ending stream, right? Maybe an infinite stream coming from a device like an IoT device, some sensors or things like that. Now you know how to use the yield return in an asynchronous manner using the async enumerable of t in combination with awaiting the for each loop directly. And that's all I got for you today. I hope I was able to help you better understand when and why you would use the yield return statement in both synchronous and asynchronous code. I would like to thank all of you for watching me today. If you have any questions, please feel free to reach out to me on Twitter at Brian Lagunas. And when you get a moment, please visit infogristthis.com, give our product a try, and let me know what you think. And please be sure to show me when you build something cool with them. All right, thanks for watching, and I'll see you next time.